Hello everyone. Today we're going to be going over how to use the Selector Module board for the PROTIS 1 series guitar effects development boards. Give me a like and subscribe if you like the video. Just want to say that out at the out front. So here's the basic board, the PROTIS 1 basic, and I'm just going to show you how I have it connected up. I have a 9 volt center negative power supply coming in, and up here is the positive and negative terminals. So you have positive 9 volts coming in, and that's being connected to the top rail, the red rail over here, and then the negative one is coming into the negative rail, and the positive rail is being routed to our selector module board, and the negative rail is connected to the other side of this LED that we're going to use for demonstration purposes. And the other side of the LED, which is the, let's say, the anode of the LED is going to be, which is the positive side, is connected to the other side of the selector module. So also sorry for the watermark. I'm going to get rid of that soon. But in any case, so here's the selector module, and I'm going to show you how it works now. So the Con1 connection up here, all of these are connected. That's indicated by this line in the center and then all the little lines over here. So these are all connected together, and on the PROTIS 1 board, on the module prototyping board space, these are all numbered R1 to R9 for Con 1. And you can see them up here. So R1 to R9, all of these, for this module board in particular, all of these are connected together. So when I connect up the positive 9 volts to here, that 9 volts is being seen all across this entire Con 1 rail. Now, this Con1 rail is connected to the common point of the 8-position switch. This is an 8-position switch, and you can see that from here, 1 to 8. It's a rotary switch. And what this does is as you turn this, the 9 volts, or whatever you have up here, is routed between position, or station, I should say, station 1, 2, 3, 4. And each of those stations are shown here. 1, 2, 3, 4, 5, 6, 7, and 8. Now, there's 8 stations here representing each position of the switch. And it's better if you see it up this way. So over here, for this one station, for example, the first point here and the second point here are connected together. And it's the same, and it's, well, no, so these are connected together, and then the ones on the bottom here, on the bottom here, are connected together. And you can see that from here. Actually, in the bottom one, they're all connected, and they all go to con 2. Okay, but let's just focus here first. So in this first position here, these first two are connected. Now on this portion, you could see that if we could bring it a little closer for you, right? There's a line from here to here, and from there to there. And so internally, the top left one is connected to the bottom left one, and then the top right one, is connected to the bottom right one. So that's how those are internally connected, and that's shown here with the little line in the center there. I don't know if you could see that, but the top left one and the bottom left one are connected, and the top right and the bottom right are connected together. Now, those are floating unless you connect something to them. Those are floating, so they don't matter unless you use them. But the bottom one over here is connected together. They're actually all connected together, and they're all connected to Con2. Con2, these are all connected, and from L1 to L9, those are all connected. So it doesn't matter which one you put them in, which one you connect to, it will connect to this entire bottom row. So the only part that switches is up here. You have bus 1, bus 2, bus 3, bus 4, bus 5, bus 6, bus 7, bus 8. Now, I have a LED connected here, and I have a bunch of 1.5 k ohm resistors here connected in different configurations. So right now we're in position 1, and position 1 has nothing in it, as you can see. So the LED is off. But when I put it into position 2, I have two LEDs here, and they're connected in parallel. This is how you connect them in parallel. You have a 1.5 and a 1.5, which if I change my thing here, if we do 1.5 k ohms and 1.5 k ohms, we will get, and this is in parallel, we will get 750 ohms. So that's what we're seeing right here, and that's what the LED is seeing in front of it. Now, when we switch it to the third station here, so I'll do that. You can see the LED got a little bit less bright. Okay. Now for here, we just have a 1.5K connected from bus 3 or switch 3 over here, position 3, whatever you want to call it. And that's going to con 2. So now we have 9 volts coming in, going into position 3. Position 3 is over here, going through the resistor, down into connection 2, which is going to this side of the LED and then down to ground. And so this is a 1.5K. This is a simple 1.5K resistor here. And then in position 4, and this is where this is probably the most complicated. If we go to position 4, that's even less bright. So why is that less bright? That's because we have two 1.5K ohm resistors here in series. And so I probably don't need to do this for you, but when we have two 1.5K ohm resistors and we calculate them in series, we get 3,000 ohms. So that's actually more resistance, and that's going to give you um, a less bright LED. So I hope this demonstrated for you how to use the selector module in a way that's practical, and I hope you can see how you can use it in your own designs. So if you can use this for diode configurations, capacitor configurations, resistor configurations, and it's just really a useful tool. So thanks for watching. Please like and subscribe, and have fun.